All right, we're live. Hello, hi, good afternoon, everybody. How are you doing today? I'm Anushri, your teacher, your mentor, and I welcome you to this brand new one-shot session in which we are covering 11th grade topics, right? So today's topic is kinematics, and this is second part of kinematics, right? So basically, in the previous session of kinematics 1, we covered motion in one dimension, right? Basics of motion and motion in one dimension. Today, we are covering motion in two dimensions and relative motion. So, before we go ahead with this session, come on guys, tell me quickly, am I audible properly? Am I visible properly? Everything's fine with, well, there is no technical issues, right? Come on, tell me quickly. I can see a few people are already here. Hello, Divyanshi. Hello, good afternoon. Hello, Bhatinda. Well, I'm pretty sure your name is not Bhatinda, right? So, come on guys, tell me what your names are. And quickly tell me what, am I properly audible? Am I properly visible? Yeah, so that we can continue with today's session. Right. Now, see, the thing is, we are doing these one-shot sessions targeting NEET 2020, right? So I am pretty sure you guys are thorough and, well, you guys are going along with me in your revision, right? So before attending these sessions, I would say, as I always say, right, keep revising NCERT textbooks. Solve the questions from NCERT textbooks, revise NCERT textbooks, and then come to these sessions. Then these sessions will be very, very helpful for you. And after the sessions are done, after the sessions, we have session notes, right? In the session notes, we give you mind maps as well. They also are really helpful. I'll tell you at the end of the session what to do with mind maps. All right, I can see some thumbs up. That means no technical issue. You can hear me clearly. You can see me clearly. And hello, Devendra. Hello, Pragati. Hi, Riya. Good afternoon. Hello, Neha. Good afternoon. Good afternoon, Rohit. Hello, Meer. Mamta. Hello, good afternoon. Hi, Divyanshi. Thanks for confirming. Everything's good. Hello, Jeevan. All right. Hello, Apna. Good afternoon. Andrasi. Hi. Mehtab. Hello. Hello, Saranya. Hi, Rohit. Hello, Ravi. Good afternoon. Hello, Saikat. All right. I can see everybody is in good spirits and you guys are ready to revise 11th grade topics, right? Ready to revise kinematics. So, just like in other one-shot sessions, what we are going to do is we are going to start with the basic concepts and then build up on those concepts and go for applications of those concepts in the relevant questions, right? So, the questions that generally come in NEET. Let's move on. Let's start. In today's session, we are going to cover, as I told you, we're going to start with motion in two dimensions. In motion in two dimension, there is a particular kind of motion, projectile motion, that is really, really important, right? Then we'll start with relative motion, general relative motion, and then one particular case of relative motion, which is riverboat problems. Riverboat problems, again, they come a lot in, they're pretty important in NEET, right? Okay, all right. Let's go. Let's start with the first one, right? Motion in two dimensions. So we have understood the basic of motion in one dimension, right? In the previous session, and we've understood the applications as well. In motion in two dimensions also, the basic parameters remain the same, right? It's just that now the motion is not happening along a straight line, but it is motion on a plane. Right. So to find out different parameters, right, to find out velocity, to find out displacement, acceleration, and so on, we need to look at the parameters along two axes, right? So we're going to say by default, we're working in XY plane. And when motion is, when the body is moving in a plane, then we can say that we are looking at parameters along x-axis, along y-axis, right? Okay. So any vector, and you understand, in kinematics, we are dealing with these parameters that are mostly vectors, right? We've got displacement, which is a vector quantity, velocity is a vector quantity, acceleration is a vector quantity. So if you have vector in a plane, any vector in a plane, you can always resolve it in two components, one along I cap, one along j cap. Right. So here also, if I have any general vector in a plane, let's say this is the v vector that I'm talking about, then along x-axis I can resolve it as vx, x component, and along y-axis I can resolve it as vy, y component. And then the general vector can be written as v vector is equal to vxi cap plus vyj cap. You know this already. This is the basics, right? All right. So motion in two dimension, as I just said, motion of an object when it is restricted within a plane, then it is said to be motion in two dimension. Now, 2D motion, when we're talking about, see this ball over here, restricted in this plane. Now, when we talk about 2D motion, right, as I told you, we are looking at parameters along x-axis and along y-axis. So effectively we can say that the parameters are changing along x and y-axis simultaneously. Okay? So if I say the particle moves from this point to this point, I will say that if this is x-axis, this is y-axis, then the particle has moved this much effectively, but then it has moved simultaneously along x-axis and along y-axis as well, right? So effectively we can say that if it is moving simultaneously along x and y-axis, and if we talk about z-axis in case of spatial motion, then also simultaneous motion is happening, right? So the basic idea in 2D motion, and later on we can take it to 3D motion as well, is that time taken to cover x direction motion is equal to time taken to cover y direction motion, because they are happening simultaneously, right? When the ball went from initial position to final position, this is initial position, this is final position, then I will say that it covered displacement along x simultaneously with displacement along y. Okay, so time taken for x direction is equal to time taken for y direction, and if we go one step ahead and say that this is motion happening in space in 3D, then this will also be equal to time taken along z direction. Okay, now this I'm telling you beforehand because this is a very, very general, very, very basic understanding of motion, 2D or 3D motion, and we are going to apply this concept everywhere. Okay, so any general 2D motion, projectile motion, relative motion in 2D, riverboat problems, later on you can have relative motion in 3 dimension. You keep going ahead and ahead and ahead, doesn't matter, right? The basic fundamental still remains the same. We will keep applying this. Now, as we said, it's simultaneous, independent 1D motions. So we'll say that net motion is the vector superposition of the motion along x and y axes, right? And here we are using the fundamental of vectors, that vector mein kya hota hai? See, when we do components of a vector, right, when I say this is a general vector, it can be split into x component and y component. Then whatever is happening along x direction will not depend on y direction, and whatever is happening along y direction will not depend on x direction. Okay, that's the basic idea. So you can calculate x direction motion parameters separately, you can calculate y direction motion parameters separately, and then take them together, right? Take their resultant and find out the net. Very simple. That's the basic idea of the entire 2D motion, right? मैंने एक line में बता दिया आपको. Okay, now let's look at these applications over here, right? So I can say that let's start with position vector, right? हमने last session में position vector in 1D देखा था, right? Now the same idea can be extended in 2 dimension also. We can say that yes, position vector is vector that defines the position of a particle, vector going from origin to position of the particle. If r vector is the position vector, if p is the position of the particle, x comma y are the coordinates, then r vector is equal to xi cap plus yj cap. And this again can be extended to z direction also. So if the coordinates are x comma y comma z, I'm going to write it here. If the coordinates are x comma y comma z, then position vector will just be xi cap plus yj cap plus zk cap. Is that fine? All right. Now, yes, Ehsan is saying frame of reference. Yes, Ehsan, again, just like understanding of any motion, right? Just like analysis of any motion, in 1D motion also, 2D motion also, 3D motion also, frame of reference is really important. Last session में हमने frame of reference cover किया था. इस session में हम उसी understanding को लेके चलेंगे, right? Okay. Now let's go to how to analyze 2D motion, right? अब मैंने simply तो बता दिया आपको. I have told you in one line what 2D motion is. It's simultaneous motion happening along X and Y axes, right? Okay. So now, how to go about analyzing, how to go about solving questions? I will say that whatever kind of 2D motion that you have, we have very simple segregated steps that we can follow. Okay. First things first, choose an origin and establish positive sense of two axes, right? As we said, frame of reference. That means choose a frame of reference. Choose coordinate axes. You have origin and two axes, right? Understand what is positive, what is negative direction. Right, positive x-axis, positive y-axis. Then resolve every given vector along x and y-axis, right? That's the second step. Whatever vectors that you have, whether you have displacement, velocity, acceleration, resolve them along x and y-axis. Then you can tabulate separately for x and y, right? Separately you can calculate for x-coordinate, x-axis parameters. Separately you can calculate for y-direction parameters. How? Apply suitable equations, right? Apply suitable equations of motion. We already have seen equations of motion, and then at the end of the day, you can relate them back, all right? Because time variable is common for both, right? So effectively, I can say that time taken for x direction motion is equal to time taken for y direction motion is equal to time taken for z direction motion. If we are talking about 3D, if you're talking about 2D, then x and y only. Okay, right. Now, let's go forward. Let's look at position and displacement vector and see now. Here, this is a very quick recap for you because we have done what position vector is in the previous session, right? So what is position vector? A vector that represents position of a particle in magnitude and direction with respect to origin of a coordinate system. Here, you can see that our vector is xi cap plus yj cap. Now, if I talk about displacement vector, then if a particle has moved from initial position to final position, here the particle has moved from point P to point Q. I have P's coordinates x1, y1, I have Q's coordinates x2, y2. Then I can say that displacement vector will be vector going from P to Q, right? And it can be written in terms of position of P and position of Q. Basically, displacement vector will be delta R vector, right? This is RQ vector minus RP vector. This is equal to, yes, x2 minus x1 I cap plus y2 minus y1 j cap. Is that fine? All right. Now, we have understood what position and displacement are. Let's go to velocity. Again, for 1D, we have already seen what velocity is, right? But we have only done it in 1D. Now we are going to extend that concept, all right? That's all. Basic remains the same. So, what is average velocity? Average velocity is displacement upon time, right? Right. Displacement is a vector, so average velocity is also a vector. Okay. Now here we already saw what is displacement, delta R vector, right? So this is delta R vector upon time. This is average velocity. And this will be this vector. Do you see that? This is delta R vector. As you can see, average velocity is equal to delta R upon time. That means direction of average velocity will be in the same direction of delta R vector, right? Displacement vector. So here I can write it as delta R vector. I can write it as S vector also. Okay? That's it. This is average velocity. Now, when I actually substitute the value of S, right? Substitute the value of displacement. Then I can say that displacement is equal to what? x2 minus x1 I cap plus y2 minus y1 j cap. That is what? Delta x I cap plus delta y j cap. If I substitute it here, then I get delta x by delta t I cap plus delta y by delta t j cap, right? What does that mean? Delta x by delta t is velocity's component in x direction, right? Delta x is displacement in x direction, divided by delta t gives you velocity in x direction. Similarly, delta y is displacement in y direction, divided by delta t gives you velocity in y direction. Simple. So this tells me that here we go, average velocity from P to Q will just be Vxi cap plus Vyj cap, or rather I can say that this is equal to Vx average I cap plus Vy average j cap, right? Okay, that's it. Now let's go and let's look at the direction of average velocity, right? Direction of average velocity is, yes, along the displacement vector. What about instantaneous velocity though? Yeah. Instantaneous velocity, as we talked about in the previous session, is when you take the delta t, right? Time interval, time duration, and take it very close to zero. Okay, limit delta t approaching zero. That becomes instantaneous at that instant. What is instant? An instant is a very small duration of time, right? So again we will go and apply the same understanding, and we will say that here we go, instantaneous velocity is equal to, yes, Vx I cap plus Vy j cap. Now here this Vx and Vy are instantaneous velocity in x direction, instantaneous velocity in y direction at that particular instant. And what is the direction of instantaneous velocity? Direction of instantaneous velocity will always be along the tangent to the path. Okay, so whatever kind of path it is, I can talk about any general path. Okay, let me do this. Here I have this particle, all right, can you see this? Moving in this, right, random kind of a path. Okay, so if this is the kind of path, then I will say that at this point A, when the particle is at point A, make a tangent, this is the direction of velocity. When the particle is at point B, make a tangent, this is the direction of velocity. When the particle is at point C, make a tangent, this is the direction of velocity. Okay, so this is xy plane. In xy plane, you can see that velocities, instantaneous velocities direction is always along tangent to the path at its position in that instant. Okay, right. Okay, let's move on now. As we can understand, this is equal to instantaneous velocity. This is also ds by dt, right? Yes, differentiation of displacement with respect to time. Now let's go to acceleration. What is acceleration? Acceleration is rate of change of velocity with respect to time, right? So if I talk about average acceleration, it will be delta v by delta t. And if I talk about instantaneous acceleration, it will be dv by dt. Right? So just like we looked at velocity, we can look at acceleration also, and we can say that here we go, average acceleration is equal to delta Vx I cap plus delta Vy j cap upon t. That gives you delta Vx by delta t I cap, delta Vy by delta t j cap. What is this? This is again average acceleration in x direction I cap plus average acceleration in y direction j cap. Alright? Again, applying the same fundamental, we can talk about instantaneous acceleration, right? Okay, instantaneous acceleration is, yes, this is equal to, A is equal to dv by dt. Now when I talk about v, dvx by dt is ax and dvy by dt is ay, right? So instantaneous acceleration in x direction and instantaneous acceleration in y direction, it's resultant. Okay. So till now, you can understand that when we are talking about velocity or acceleration or displacement, what we have done till now is, we have said, okay, if x is the displacement in, x direction, then dx by dt gives me vx, and then dvx by dt gives me ax, right? Similarly, dy by dt gives me vy, and d by dt of vy gives me ay. Okay? That's about it. Now, when we talk about directions, in case of instantaneous velocity, it was always tangential to the path. In case of instantaneous acceleration, it is along dv vector. Okay? Not along v vector, but along dv vector. Alright. Similarly, direction of average acceleration is along delta v vector, right? Change in velocity vector, delta v vector, and here this is parallel to dv vector. All right. Now that we've understood this much, right, and we'll be applying all of this in questions, in separate scenarios. Let's move on. Let's solve a question. Okay? All right. So here we go. I've got a question for you. Quickly solve this. Quickly tell me what the answer is coming about. Simple direct application of concepts that we have learned. Okay? So here we say the position of a particle is given in terms of I cap, j cap, k cap, right? 3t I cap plus 2t square j cap plus 5 k cap. T is in seconds and coefficients have proper units for r to be in meters. Okay. We have to find out two things. First, v as a function of time and a as a function of time of the particle, right? V in terms of time and a in terms of time. Second thing is find the magnitude and direction of v at t equal to 1 second. All right, velocity at t equal to 1 second. So let's do this one by one, right? We can see that particle's position is given in terms of I cap, j cap and k cap. What does that mean? It means that the motion's happening not just in 2D but in 3D, right? But don't worry, whatever concepts we are applying in 2D, same analogy can be extended to 3D, right? Yes. So here I can say that, what is the first thing that's given to us? It's given that r is equal to 3t I cap plus 2t square j cap plus 5 k cap. Now tell me quickly, what is velocity vector? V is equal to dr by dt, right? Yes. Ehsan has answered 3 I cap plus 4 j cap. Okay. What about the first part? Velocity is a function of time we need to find out, and acceleration is a function of time, right? In the first part, velocity is a function of time and acceleration is a function of time. So what do? We say that velocity is equal to dr by dt, right? Velocity is dr by dt, and when I substitute, I will say that, here we go, 3t I cap, 3t, differentiation with respect to time will be 3. So 3 I cap. Differentiation of 2t square will be, yes, 2 into 2t, which is 4t. And then differentiation of 5 is a constant, this is 0 k cap, right? So velocity is 3 I cap plus 4t j cap and plus 0 k cap. What about acceleration? Acceleration will be equal to, yes, further differentiation, dv by dt. Here we get 0, acceleration is equal to dv by dt, which is equal to 0 plus 4 j cap plus 0 k cap. That means 4 j cap is the answer for acceleration. Okay, that is it. That's good. Ehsan, Bikash, I see that you've, Devyani, yes, 4 j cap, that is acceleration. Now, the second part of the question. Velocity at t equal to 1 second, right? That's what we have to find out. Let's see. Magnitude and direction of velocity at t equal to 1 second. What is that? We have already calculated velocity as a function of time, right? Yes. So now I can say that we've already calculated velocity as a function of time, which is 3 I cap plus 4 t j cap. Now we just have to substitute t equal to 1 to find out velocity at t equal to 1, right? Very simple. Here we go. This becomes equal to 3 I cap plus 4 j cap, right? Okay, velocity at 3 equal to 1 second is 3 I cap plus 4 j cap. What is the magnitude now? 3, 4, 5, right? So magnitude will be root over of 3 square plus 4 square. That is equal to 5 meter per second. And direction can be calculated using, yes, tan theta. So I can say that tan theta is equal to 4 by 3. See here, if I have a vector that is 3 I cap plus 4 j cap, that means it's like this, right? This is 3, this is 4. And I can say that this angle is theta. Tan theta is equal to 4 by 3, right? Which gives me theta is tan inverse 4 by 3, which is 53 degrees, right? So then, what do I say? Velocity makes 53 degrees or tan inverse 4 by 3 with x-axis. All right. 53 degrees, aims, make sure life will be wonderfully live. Great. All right. What is your name, man? Okay. Yes, the answer is 53 degrees. And let's move on now. Okay, 5 meter per second, 53 degrees. See, now we've understood what to do in 2D motion, right? General 2D motion and general 3D motion also. Now let's go and apply that in a specific type of 2D motion, which is projectile motion. Alright, so now I know you guys have well studied projectile motion and yes, gone through projectile motion and so on and so forth. And you know that questions from projectile motion definitely come, right? In NEET, in JEE also, in NEET also. So let's go ahead, let's learn this properly and let's apply concepts. Now projectile motion also is a very straightforward, very simple topic, right? All you need to do is understand the basics and apply the basics. That's all, right? Okay, yeah, Rohit. Your name is Rohit. All right. So what is projectile motion basically? See, we did motion under gravity in one dimension, right? In the previous case, basically, if you take a ball, throw it directly up, what happens to it? It goes up, comes down, right? Now, if you take the same ball and instead of throwing up, you throw it at an angle, right? What happens to it? You throw it at an angle and it is going to go, yay, like this, right? So it's going to go forward also and it's going to go up and down. There we go. That is our 2D motion. So we can break it into two parts. We can say that the up and down motion, right? That is the same motion under gravity that we talked about earlier. The up and down motion. The second part of it is simple forward motion, right? There we go. We have one motion in x-axis, one motion in y-axis, right? Just like this ball. Do you see the path over here? This is the path that the ball is following. And in a projectile motion, motion under gravity, 2D motion under gravity, the path is a parabolic path. All right? Okay. Now, if I talk about at launch angle theta, right? Say you are sending this projectile at an angle theta, then of course, theta is between 0 to 90 degrees. Initial velocity is u, velocity with which the projectile is projected. And both u and theta, these are the two important things that determine the path of the projectile, right? You know this already. Now, when we talk about instantaneous velocity of the projectile, right? What happens to it? Well, think about it this way. The projectile is going along this parabolic path. This is a 2D motion. What happens in any general 2D motion? Right? Velocity's direction is along the tangent. So initial velocity is like this, velocity over here is like this, velocity over here is like this, and so on and so forth. What about acceleration? Acceleration is acceleration due to gravity only. That is only in vertically downwards direction. This is acceleration, right? Okay. Acceleration is constant acceleration, acceleration due to gravity, and because of this, when we divide it into two components, when we say alright, x direction component and y direction components, in x direction there is no acceleration whatsoever, right? So in x direction this is going to be very similar to uniform motion, and in y direction it is motion under gravity, simple motion under gravity, right? Okay. Sakshi, you have a test on kinematics tomorrow. All right, good. You've come to the right place then. And Devendra, projection on incline, yeah? Projection on incline is, we're not doing that today, all right? But the fundamentals are the same, all right? So you don't need to memorize any formulas. I'll tell you how to solve questions, okay? Now, important terms in projectile motion, right? What are the different terms that we are looking at? For any projectile motion, right, we are looking at three important terms: time of flight, maximum height, and range. What is time of flight? As I told you before also, time of flight is the time for which the body is flying, right? How long does the body fly? The time for which it is in air. That's all. The time for which it is in motion. Maximum height, the maximum height that it attains from the level from which it is projected, level from which it is thrown. Range, That is the horizontal distance, horizontal displacement covered by the projectile. Okay. Now, let's look at how we can take components. So as I told you, right, take all the vectors that are there in the motion, right, displacement, velocity, acceleration, and take their components in x and y direction. That's the first thing in analyzing any kind of 2D motion. So in projectile also we will do that, right? Okay. So what do? We say that, all right, in x direction acceleration is 0. It's a uniform motion in x direction. In y direction acceleration is g vertically downwards, right? That is why minus g. And in z direction, nothing. Of course, it's a plane motion. So acceleration is just minus g j cap. That's all. Now, when we talk about velocity, if I say initial velocity is thrown at an angle theta, then in x direction it will be u cos theta component, in y direction it will be u sin theta component, right? And the net velocity will just be the vector addition of these two, ux I cap plus uy j cap, which is, there we go, root over of u cos theta whole square plus u sin theta whole square, which is u. Very simple. Right. Now, let's see. We can apply equation of motion, right? We can say that along x-axis, this is uniform motion, and along y-axis, this is uniformly accelerated motion, uniform acceleration. That means three equation of motions that we saw, v equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as, all three will be applicable here in y direction. Okay? Right. Now let's calculate the three parameters that we talked about: time of flight, maximum height, and range. Okay. Here also, you don't need to memorize anything. Alright. We will just take what we did in the previous 1D motion and apply the same analogy over here. Okay. So now pay attention. If I take a ball, right, and throw it up with you, how much time will it take to come back down? We did this yesterday, right? If I take a ball, throw it up with you, it's going to take 2u by g to come back down. So now if I take a ball and throw it up with u sin theta, how long will it take? Yes, 2u sin theta by g, right? Instead of u, I'm throwing it up with u sin theta now. That's it. There we go. That is our time of flight, right? Time of flight for a projectile, 2u sin theta by g. Now, let's go to maximum height, right? Again, maximum height, if I take a ball, right, and just throw it up with you, how far ahead it will go? How high will it go? It will go u square by 2g. We've done it yesterday, right? Or in the previous session. So now I'm taking the same analogy and I'm saying if I throw it up with u, it goes up by u square by 2g. If I throw it with u sin theta, it goes up till, yes, u sin theta whole square by 2g, right? What are we doing? We're replacing u with u sin theta. That's it. That's the maximum height, u square sin square theta by 2g. Simple? Alright. Now let's talk about range. Now what is range? Range is actually, horizontal range is actually displacement along x direction, right? So we've seen y direction, we've seen that time of flight, calculated. Maximum height, calculated. Those were both along y direction, right? Now, why is time of flight along y direction? The thing is, the ball is coming back and the motion is ending only because you have gravity in y direction, right? Right. And that is why to calculate time of flight, we are looking at y direction motion first. In x direction, there is nothing to stop the motion of the particle. So there is nothing to make the time of flight finite, make the time of motion finite. Do you understand that? All right, all right. So let's come back to horizontal range. So what are we talking about? We're talking about horizontal displacement, which is uniform motion, right? So displacement for uniform motion is nothing but velocity into time, right? Now in horizontal direction, velocity is u cos theta into time is, we just calculated time of flight, right? Time for which motion is happening, 2u sine theta by g, multiply them, you get range. There we go, right? And so simplify this, what do I get? U into u square, 2 sine theta cos theta sine 2 theta divided by g, right? U square sine 2 theta upon g. Very simple. Alright, now what about next thing? Velocity of the particle at any given instant, right? What are we doing here? We're taking this projectile ground to ground and doing complete analysis of it, right? So, if I talk about velocity, I've already said that velocity of a particle in 2D motion is always tangential to the path. So, this is a velocity tangent at this point, right? Now, this velocity is going to have two components, x component and y component, right? And I can say that final velocity vector v vector is equal to nothing but vx I cap plus vy j cap. So now all I need to do is write these two and we get our velocity vector. So in horizontal direction, if I talk about x component, it's a uniform motion, right? So in horizontal direction, if it is a uniform motion, then uniform velocity is not going to change in horizontal direction. That means ux, which is u cos theta, is vx as well, right? So I can say that vx is equal to u cos theta. Alright, what about in y direction? In y direction, it's a uniformly accelerated motion. So if I say that upward is positive, downward is negative, I can apply v equal to u plus at and say that, there we go, vy is equal to u plus at uy minus gt, right? I can substitute these values. I can say that vy is equal to uy, which is u sine theta minus g into t, time of flight, 2u sine theta by g. So 2u sine theta by g. This gets cancelled out. This becomes rather vy is equal to uy minus g into time, right? Whatever time it is. Here it will be some time t, and if I want to calculate for final, then I'll say time of flight. Okay? So now that we have vy equal to uy minus gt, I can just substitute here and I can say that velocity vector is equal to u cos theta I cap plus u sine theta minus gt j cap. Is it fine? Alright. Now, alright, I can see that Hassan, Khushbu, you guys are good. Anybody who has any doubt whatsoever, keep asking in the chat window. Alright? Okay. Now let's solve this question. Here we go. Simple application of concepts, but important to do. Okay? So, quickly solve this. I have a question here. Write the answers in the chat window. A ball is thrown at a speed of 50 meters per second at an angle of 60 degrees with the horizontal. Find time of flight, maximum height and range of the ball. G is 10 meters per second. Okay? 10 meters per second square. So, what do? Come on guys, quickly tell me what the answer is. You have u equal to 50 meters per second and theta is equal to 60 degrees. Tell me what the answer comes out. Time of flight, maximum height and range. You know the formula is, you can apply this. Quickly tell me what the answer comes about, so that we can move on to the next question. Okay? Alright. For time of flight calculation, t is equal to 2u sine theta by g. 2u 50 sine theta sine 60 degrees root 3 by 2 divided by g, which is 10. Right? This gets cancelled out. We have 10 into root 3 by 2, which is equal to 5 root 3 seconds. Alright. 10 into root 3 by 2, right? This 2 also gets cancelled out. So, 5 root 3 seconds. What about maximum height? Maximum height will be u square sine square theta by 2g. Again, just apply the formula, right? So, maximum height will be u square, which is 50 into 50 sine square theta, right? Sine theta is root 3 by 2, sine square theta is 3 by 4. So 3 by 4, 2g, 2 into 10. Here we go, right? This gets cancelled out, and then we've got 50 divided by 2, which is 25. So here we've got 25 into 3 by 4, 75 by 4, right? All right, 75 by 4 is the answer over here. Now, let's move on. Let's go to the third part. Third part is range u square sine 2 theta by g. So, what is the answer that comes about? Yes, u square 50 into 50 sine 2 theta, yes, sine of 120 degrees will be the same as sine of 60 degrees, right? Okay, so root 3 by 2 divided by g, 10. Here we go. We get the answer as 50 into 5, 20, yes, 25. 25 into 5 is 125, 125 root 3. All right? Okay. So, now that we've understood how to apply these equations, well, we've done the basics, right? Let's move on. Let's find something more challenging, right? Okay. Now, when we talk about range is u square sine 2 theta by g, and range will be maximum when? Range will be maximum when theta is equal to 45 degrees. Alright? And maximum range will be how much? U square by g. Now think about it. In range, you have the term of sine 2 theta, right? It will be maximum when the value of sine 2 theta is maximum, which is 1. Right? If sine 2 theta is 1, that means 2 theta is equal to 90 degrees and theta is equal to 45 degrees. Very, very simple to understand. Right? Okay. Now, for objects projected at complementary launch angles, range will be the same. Right? The second thing. If we have objects projected at complementary range angles. Why? Because if we talk about range, then I can say that sine 2 theta is nothing but 2 times sine theta cos theta, right? Now, if I replace theta with 90 minus theta over here, right? If I say this is 90 minus theta and this is also 90 minus theta, sine 90 minus theta cos 90 minus theta, then I can say that sine of 90 minus theta is cos theta and cos of 90 minus theta is sine theta. So effectively I've got the same expression 2 cos theta sine theta, which is sine 2 theta, right? Yes. So we will say that for two complementary angles, alright, for two complementary angles, range is going to be the same, always. If I look at how this looks about, right? If I look at how range looks at for different angles for projection, we can see that for 15 degrees, see, we've got a smaller range. As you increase the angle, 30 degrees, we get range a bit bigger. 45 degrees, even bigger. But then if we increase the angle after 45 degrees, we get for 60 degrees, again smaller range, and for 75 degrees, again smaller range. Right? And you can see that range for 30 and 60 degrees are the same, range for 15 and 75 degrees are the same if you keep initial velocity of projection constant. Okay? Alright. Now that we've done this, let's go solve another question. Okay? Here we've got a question. An object is projected with the same speed at two different angles. Right? It covers the same horizontal range R. See? We just did this. If the two times of flight are T1 and T2, then what is the value of half G T1 T2? Alright? Mohit is asking, please clarify in the previous question, maximum height should be 375 by 4 or what? Hey, just apply the formula. Okay, so u square sine square theta by 2g and substitute the values. U is equal to 50 degrees, theta is equal to 60 degrees. Your answer, whatever comes out, is the answer. Alright? Okay. Now, let's come over here. Mohit, is that clear? Just apply the formula, alright? When you calculate, what answer comes about is the answer for you. Okay. Now, let's solve this question. Come on, guys. Till now, we were just applying the formula, right? Now, let's apply concepts. So, an object is projected at two different angles, same range, that means they are complementary angles, And if they are complementary angles, T1 and T2 are the times of flight for them. What is the value of half G T1 T2? Come on. What is the value of half G T1 T2? Options are R, 2R, 4R and R by 2. So how do we start? A, B, C or D? Alright, I have started receiving answers here. Praveen says A. Ehsan says B. Alright. Any more options? Okay, let's see. Now again, these kind of questions, you should be able to do them within 60 seconds. Alright. That is the time limit. Okay, Arghya says A again. Alright. Ames says D. Okay, Surat says B. Let's go. Let's find out. So we have two angles that are complementary to each other. One is theta, one is 90 minus theta. Right? So let's see what's going on. Here we've got theta and the other is 90 minus theta. Both are projected with the same initial velocity. Right? So now range is u square sine 2 theta by g. And since options are in terms of range, right? We want to keep this relation in mind. Okay. Now, we're talking about times of flight. So, T1 will be how much? First time of flight will be 2u sine theta by g. For second time of flight, we need to apply? Yes, 90 minus theta. So, second time of flight will be 2u sine of 90 minus theta by g. Sine of 90 minus theta is cos of theta. So, 2u cos theta by g. Now, we want to find out the value of half g T1 T2. G by 2 T1 T2. Right? So, T1 T2 will be equal to, just multiply them. 4u square sine theta cos theta by g, and this is 2r by g, isn't it? 2 sine theta cos theta is sine 2 theta and u square sine 2 theta by g is r. So now this comes about as 2r by g. What do we want? We want the value of g T1 T2. G T1 T2 is 2r. Alright? Okay. What answer is this? 2R is option number B. So option number B is the correct answer. Okay? G T1 T2 is what we talked about. Alright, I hope you guys understand this, right? Let's move on and let's go to landing velocity, right? So next thing about projectile motion is, yes, we've talked about how much time it takes. We've talked about how high it goes. We've talked about how far it goes horizontally, right? Now we will talk about what is the landing velocity. What is the velocity with which it lands, right? Now here as well, think about it. Effectively, projectile motion is nothing but combination of two parts, which is, one is simple motion under gravity in y direction. The second part is horizontal uniform motion, right? Yes. So now if I talk about landing velocity will also be final velocity of two parts, which will be one final velocity Vx, the other will be final velocity Vy, right? These are the two components. Now, if I look at x direction, in x direction there is no acceleration whatsoever. Velocity is not going to change. So it will remain ux, which is u cos theta, right? But in y direction, it changes, right? So I can say that Vx is nothing but u cos theta, but Vy changes. And now if I look at my basic understanding of what happens in one dimension accelerated, uniformly accelerated motion under gravity, right? We've done that. What happens when you throw a ball? You throw a ball up, it goes up, comes back. Time taken to go up is equal to time taken to come back. And the speed with which you throw up is the speed with which it comes back. You know this, right? So now we're applying the same funda. Here, the speed with which I'm throwing it is uy, u sine theta. So it should come back with u sine theta only, right? So now I will say that the speed with which it comes back will be u sine theta. here we go. So final velocity in y direction, u sine theta, final velocity in x direction, u cos theta. What is the resultant of these two? The resultant is u. There we go. V is equal to u. Landing velocity's magnitude is the same as initial velocity's magnitude. The angle. If we talk about angle, the angle with horizontal at which it lands is also the same as angle of projection. Why? Because if now we say mod of Vy by Vx, it will come out tan theta only, no? Right? This divided by this divided by this, tan theta, right? Okay, all right, we understand this. Let's move on now. Let's solve another question. If a projectile crosses two walls of equal height, h, simultaneously as shown in the figure, then choose the correct statement. What happens? Time of flight is 10 seconds, height of each wall is 80 meters, time of flight is 12 seconds, height of each wall is 60 meters. So basically, we have to check two values in this question, right? Come on, quickly tell me, in this scenario, what is the time of flight and what is the height of the wall? Yeah? Here it's given that initial velocity u, it's not given to us. There are two walls of equal height. It crosses the two walls, right? It goes through these tops of two walls. First wall it crosses at t equal to 2 seconds. Second wall it crosses at t equal to 6 seconds. The distance between the two walls is given as 120 meters. Okay? Come on. Quickly tell me what is the answer. What is the time of flight? Time of flight we can calculate. Actually, we don't really need to calculate, okay? We can just look at the symmetry. In a ground-to-ground projectile, there is a very, very beautiful symmetry that we're talking about, right? There is a beautiful symmetry here. See, in ground-to-ground projectile, you will always see that, see, this is the line of symmetry, okay? Everything to the left of line of symmetry is exact mirror image of everything to the right of line of symmetry, okay? How? See, the speed with which you throw up is equal to the speed with which it comes down. Time taken to cover this much motion, left side, is equal to time taken to cover right side motion, right? Also, time taken to cover this much portion will be equal to time taken to cover this much portion. Right? Again, symmetry. Look at it. Any two positions that are mirror image of each other, they will be completely symmetric here. So, if I say that, all right, people have started giving options, huh? I can see B, life, wonderfully life. Then I've got Divyanshi saying B, Ehsan saying C and D. All right, you're getting C and D both. Let's see. So, do you see this? If I apply the symmetry, right? I will say that time taken to go from here to here. Let's name points, yeah? A, B, C, D. Here I've got points. Time taken to go from A to B should be equal to time taken to go from C to D, right? Time AB is equal to time CD, right? So, if time taken to go from A to B is 2 seconds, from C to D also it should be 2 seconds. Yes. Now, there is another time given here, time when it crosses the second wall, right, which is C. Time taken to go from A to C is given here as 6 seconds. See, from here to here, it is 6 seconds. So, this is 6 seconds. This is 2 seconds. What is the total time? Total time will be 6 seconds plus 2 seconds, right? So, time of flight comes out to be 6 plus 2, which is 8 seconds for this particular motion, right? Okay. Now that we've got time of flight and it is not matching with any options, we'll have to calculate height of each wall, right? And how do we calculate height of each wall? We will say that if I have time of flight, I can say that, well, here we go. Time taken to go up is 2 seconds, right? Yes. And time of flight is 2u sine theta by g. So, can I get u sine theta from here? Of course I can. I'll say that 2u sine theta by g is 8 seconds, u sine theta is 40, and u sine theta is nothing but initial velocity in y direction. right? Uy. This is Uy. And now I have time taken to go till height h. I have velocity of initial velocity with which it was projected in y direction. I have acceleration. I just need to calculate displacement, right? Okay. So now I can say that in here, if you look at it, in y direction motion, in y direction, I have Uy, I have Ay, which is 10 meter per second square downwards. I have time taken, which is 2 seconds. I need displacement, s equal to ut plus half at square. I can apply that and I can find out height of the wall, right? S is equal to ut plus half at square. Height of each wall will be u sine theta into t minus half gt square. We have everything. U sine theta is 40, t is 2 seconds. Substitute, we get 60 meters as the height. Okay? So here we go. The time of flight is 8 seconds, which is not there in these options. Height of each wall is 60 meters. This is the answer. Alright? D is the correct answer. Okay, okay. I hope everybody is clear here. If you have any doubt whatsoever, do ask. And let's move on to the next thing in projectile motion, which is equation of trajectory. Okay? Trajectory means path. For any particle in motion, right? Trajectory is just a fancy way of saying path. That's all. Right? A fancy word. Trajectory is path. So now, if I talk about equation of the path, I will be talking about equation of trajectory. And this equation will be effectively equation between x and y that tells you the curves equation. Right? Okay. If x and y are linearly related, that means it is a straight line motion. If x and y give you equation of a parabola, then the path is a parabola. If x and y give you equation of a circle, its path is a circle. Right? Equation of trajectory will be circular then. That's all. So now in here, we know that this is a parabolic path. We should get an equation in x and y, that is equation of a parabola. So what do we say? We want to find out y in terms of x. I know x in terms of time. I know y in terms of time. I can find out y in terms of x. Eliminate time. That's all. Right? So along x-axis, I can say that x direction velocity is u cos theta. Right? Displacement at any given instant can be written as Sx is equal to, yes, u cos theta into t. So Sx is equal to x, which is u cos theta into t. Now along y-axis, I will say that, yes, displacement is happening for a uniformly accelerated motion. So instead of writing velocity into time as displacement, I will write it as s equal to ut plus half at square. Right? In y direction, initial velocity is u sine theta, acceleration is minus g, time is t, sy is y, s equal to ut plus half at square. Let's apply that. Right? So if I do that, what I get is, see, Sx is equal to u cos theta into t, t becomes equal to x upon u cos theta. For y direction, s equal to ut plus half at square, substituting everything, I get this. Right? And we are eliminating time. So over here we've got time, over here we've got time. Let's substitute time's value. From here, if I substitute and simplify, okay, I'm going to get a final equation of trajectory y in terms of x, right? Y in terms of x comes out to be y equal to x tan theta minus gx square upon 2u square cos square theta. Now here as well, it's really important to remember this. I know this does not look very pretty, but if you remember this, you can solve questions very easily, okay, directly. Now, we can write equation of trajectory in terms of range also. That is very, very easy to remember. Alright, so what we do is manipulate it very quickly and see here, if I multiply with sine theta in numerator and denominator, I can actually take out range from here. Okay, so I'll say that this is equal to x tan theta minus x square tan theta divided by this is range. Here we go. Y is equal to x tan theta times 1 minus x by r. Okay. Alright. So it's good to remember these two equations, these two forms of equation of trajectory. Now that we've understood this much, I hope this much is clear. Let's go and solve a question. Okay, Devendra is asking, ma'am, which will be the next class 11th chapter? See, Devendra, I am going to have a separate, right? A separate basic math basic math session as well, because a lot of you have been asking me, please do basic math session. That will contain vectors, integration, differentiation, but that will be a separate one. In mechanics, as we are continuing with the flow after kinematics, we will be doing Newton's laws of motion. All right, Newton's laws of motion, friction, work power energy, and so on and so forth. Okay. Here we have a question. The path followed by a body projected in the xy plane is given by this. If g is equal to 10 meter per second square, initial velocity of the projectile will be how much? Come on guys, quickly solve this question. Quickly tell me what is the initial velocity coming about. You have to do just compare it with the standard equation of trajectory. That's all. Okay? Come on, tell me. What is the answer coming out over here? Y equal to root 3x minus half x square is the equation of trajectory that's given here. And g is 10 meter per second square. We have to find out u. Alright, how do we start? We start by writing equation of trajectory and then comparing the given equation with the equation of trajectory. What do I say? I'll say that here see component of x is tan theta. Here component of y is 1. Here component of x is root 3. Right? That means I can say that comparing these two equations, tan theta is equal to root 3. Right? If tan theta is equal to root 3, that means theta is equal to how much? 60 degrees. Once we get it, theta is equal to 60 degrees, now it's very easy to find out u, no? Come on, quickly tell me, what is the value of u coming out? Yes, let's compare the coefficient of x square also. So, over here, coefficient of x square is minus half, over here it is minus g upon 2u square cos square theta. So, here we go. Half will be equal to g by 2u square cos square theta. Half cancels out. We get u square cos square theta equal to g. U square cos square 60 degrees equal to 10 and u comes out to be equal to 2 root 10 meter per second. Okay? Owais says, oh, you're from Kashmir. All right, great to know. Come on, quickly, keep solving questions with me and welcome Owais. Okay, so now that we've done ground to ground projectile, no? Let's move on to the next part of it, which is projectile from a height. Okay? Vijaya is from Eluru. Okay, all right. I'm a bit confused about the geography though. Where is Eluru? Vijaya? Okay. Till then, we have projectile from a height. And as the name says, right? Projectile from a height, when you throw a ball from a height, that's all. All right. Okay, Andhra Pradesh. All right, all right. So, here we've got a ball that is being thrown from a height now, right? Now, if you throw the ball from a height and if you throw it horizontally, this is called horizontal projectile. And if you throw it at an angle, this is called projectile from a height at an angle. Very simple. Okay. And we are applying basic understanding only over here. Okay. So, what happens in a projectile? We've got two motion along two axes, right? We've got one along x-axis, this is uniform motion, and this is motion along y-axis, that is uniformly accelerated motion, right? Uniformly acceleration. Okay, G, motion under gravity, right? So now I can say that, well, think about it. If I want to say, here we've got initial velocity horizontal. That means y component of initial velocity is 0, x component of initial velocity is u only, right? Alright. So now if I talk about time taken to come down, right, that will be the time of flight effectively. And time taken to come down will only depend on y direction, right? Because the ball is coming down because of gravity. Gravity is in y direction. Time of flight depends on y direction. In y direction, if I look at it, I'll say that this is a uniformly accelerated motion. Initial velocity in y direction is 0, displacement is h, acceleration is g, s is equal to ut plus half at square, right? H is equal to half gt square, t comes out to be equal to root over of 2h by g. And if we talk about range, on the other hand, range is horizontal displacement, uniform motion, time we know already, velocity into time, right? So horizontal velocity is u and time is time of flight. You substitute values, you get this. Is this fine? Okay. I hope you understand this. Now when we come to the next part of it, take it one step further. We can say that instead of throwing from a height horizontally, we are throwing at an angle, right? Okay. So if we are throwing at an angle, again the same fundamental applies. We've got horizontal uniform motion and vertical uniform acceleration. Okay. So once we have this, we can say that in x direction, ux is u cos theta, uy is u sin theta, and to calculate, we'll just say that, well, s is equal to ut plus half at square, h is equal to minus u sin theta t plus half gt square. This is one equation. We can substitute values and calculate, and if I have height, I can just calculate this, solve the quadratic equation in time, calculate the value of t, right? What about range? Once you've calculated t, you can say that u cos theta into t is range. Okay. If this is clear, let's move on. Let's solve another question, right? So here we've got two ball buildings face each other and are at a distance of 180 meters from each other. With what velocity must a ball be thrown horizontally from a window 55 meters above the ground in one building so that it enters a window 10.9 meters above the ground in the second building? Okay, these are the options. And yeah, Santosh, you've already calculated. All right. I tukka maar rahe ho kya? Hope you're not doing that. Come on, guys. Calculate, solve the question, tell me what the answer comes out. Okay? All right. So what is happening over here? We've got two buildings, right? Yeah. We've got two buildings and a ball is thrown from one building. See, I've got a figure over here. Ball is thrown from top of one building. Height is 55 meters. You need it to reach the window over here, which is at a height of 10.9 meters from the ground. Okay? The distance between, horizontal distance between the two buildings is 180 meters. So, 180 meters horizontal distance hai, and you have these two heights. So, what is happening over here? The ball is thrown horizontally, initial velocity is asked. What do? Come on. Yes, range is given to us and height is also given, right? For this particular horizontal projectile, do you see that? Effectively, the projectile is going from this to this, right? So height for the horizontal projectile will be 55 minus 10.9, which is 44.1 meters, right? Okay, all right. Using this, we can find out time of flight. Time of flight is equal to root over of 2h upon g. Substituting values, we can find out t, and once we find out t, we can say that range is 180 meters, which is equal to u into t. We have range, we have time of flight, we can find out u. Right? Okay, let's go. Let's do that same thing, right? T is equal to root over of 2h upon g and x is equal to u into t. So x becomes how much? 180 is equal to u times root over of 2h upon g. Substituting values, we get 180 is equal to u into 3. U comes out to be 60 meters per second. Okay? Answer is 60 meters per second. Santosh, if you had calculated it within 30 seconds, good job for you. Alright? So yeah, good job. 60 meters per second. Okay. Shruti is asking, how can I get full length test? Yes, Shruti, we are providing full length test to certain students. So, of course, you can join our courses. We are providing continuous full length tests in our program, all right? And with this, we are done with projectile motion. Next comes relative motion. So guys, do stay for that. And till now, I hope you've understood everything. Do tell me if you're not understanding anything, okay? All right. Shruti, you can look in the description. All the relevant links are given, okay? Now, let's go to relative motion. Yes, Shruti, because in the description you will find the full links for all the other ways to join us, right? So you will be getting full length tests over there, okay? All right. Now, let's come to relative motion, yeah? If I talk about relative motion, right, effectively every motion is relative, right? What do you have? You have a frame of reference. You have an observer that is observing the motion. So motion is happening with respect to the observer anyway, right? Now, if I change the observer, the analysis of motion changes. Say, with respect to an observer A, if you were getting velocity, say 10 meter per second, with respect to another observer B, you might get a different velocity of the same particle, right? That's about it. That's the basic concept, okay, of relative motion. Now, if I say I have two moving objects and I want to calculate relative velocity of one object with respect to the other object, yeah? If I want to calculate velocity of one object with respect to the other object, say velocity of car relative to bike, I will say that velocity of car relative to bike is v car minus v bike. Vector subtraction. Alright? If I want to do the reverse, if I want to calculate velocity of bike with respect to car, I will say that velocity of bike with respect to car is v bike minus velocity of car. Right? Okay. Let's solve a question now. Let's apply this concept. Right? Relative motion में ज़्यादा कुछ नहीं है. It's very basic. Velocity of A with respect to B is equal to velocity of A minus velocity of B. This is velocity with respect to ground or a common observer for that matter. Okay? Right. So, here we've got two velocities given, V1 vector and V2 vector. We have to find out relative velocity of the first object with respect to the second object. Come on guys, quickly subtract and tell me what comes out. Okay? Alright. V1 is given to us, V2 is given to us, we just need to subtract. V of 1 relative 2 is equal to V1 vector minus V2 vector. This is equal to 3 I cap subtraction, j cap subtraction and k cap subtraction, right? Okay, so 3 minus 2, 1 I cap plus 4 j cap minus 3 j cap, which is 4 minus 3, 7 j cap, minus 4 k cap, 0 k cap, right? There we go. We have got relative velocity as I cap plus 7 j cap. Okay. Now that we're done with this, let's move on to the next question. Okay? This is a very, very interesting one, guys. Alright? Let me tell you, we're talking about 3 particles moving here. Okay? Pay attention. Bikash, I cap plus 7 j cap. Yes, correct. Thakur Rajput, hello. Alright, yes, Santosh, it was very, very easy. Now let's come to this question. This one will test your concepts fundamentals. Okay? Okay. So, particle A is moving with a speed of 10 meter per second towards right, while particle B is moving with a speed of 10 meter per second towards right as well. Okay? And the distance between the two particles A and B is 100 meters. There is another particle C that is moving at a speed of 10 meter per second towards left. Okay. The time interval between C meeting B and C meeting A is. Okay. The time interval between C meeting B and C meeting A. That's what we have to find out. Yes, Santosh has already come with an answer. You're saying B, yeah? Okay, let's see. Let's find out. Anyone else come with an answer? So what is happening over here? We've got two particles, A and B, right? They're both moving in the same direction with the same velocity. Okay, Om also came out with an answer B. Alright, Om. So here we've got the two objects moving in the same direction with the same velocity 10 meter per second, but they have a separation between them that is 100 meters. Okay, the separation between the two objects is 100 meters. Now the third object is moving in the opposite direction with 10 meter per second, and we have to find out the time between its crossing B and crossing A. Right? So what do? In relative motion, what we do is we stop one of the bodies. See, in relative motion, you will always find more than one body is moving. Okay, more than one particle is moving. Now the basic funda here is that to stop one of them and look at the motion of the other with respect to the first. That's all. Okay. Now in here, we can easily say that since A and B both are moving with the same velocity in the same direction, if we work with respect to A, then B stops anyway, right? With respect to A, if I talk about, then with respect to A, B's velocity becomes 0 altogether, right? So effectively I can say that in A's frame of reference, A remains stationary here, B also remains stationary here, but C moves now with a relative velocity of C with respect to A, which is how much? Yes, 10 plus 10, 20 meter per second in the opposite direction, right? There we go. That's it, right? So time taken will be how much? Time taken will be separation between A and B divided by relative velocity of A with respect to C. That's all. Option number B. All right. Yes, Santosh, you're the first one to answer this question. Great job. Sapna says option A. All right. Bikash is asking how 20. Okay, think about it this way. I'm going back. How 20, yeah? See, velocity of C is in this direction, no? Towards west. Velocity of A is in towards east. So if I take positive towards west and negative towards east, I will say that velocity of C with respect to A is equal to how much? See, I'm going to write it here. Velocity of C with respect to A is equal to velocity of C minus velocity of A. If I write it in terms of vectors, velocity of C is in positive direction. So plus 10 minus of minus 10. This becomes equal to 20. Okay? All right. Santosh, you are in a good Josh. Okay. Let's move on now. Let's go to the next question. Here we've got a question. See, the thing is with relative motion, the fundamental remains the same, right? Only one fundamental. If we have multiple bodies moving, the easiest way to solve a question is stop one of them. That's all. Okay? And time taken for the motion, whether you are looking at the motion from one frame or the other frame or the other frame, time taken for a particular motion will remain the same. Okay? That's about it. Now let's solve this one. A person is sitting at the rear end of a compartment, throws a ball towards the front end. The ball follows a parabolic path. The train is moving with uniform velocity of 20 meter per second. A person standing outside on the ground also observes the ball, right? There are two people observing the ball. How will the maximum height and range seen by the thrower and outside observer be with respect to each other, right? Compare with each other. So what is happening? Two people are observing. You've got a moving train and a projectile is thrown in the opposite direction. So now there are two people observing. One person is in the train observing. One person is outside the train observing. What happens to maximum height and range? Same maximum height and range, different maximum height, same range, same maximum height, different range, or both are different. So I can see Gautam Roy says B, Santosh says C, Sharda says C, okay. Praveen says B, Santosh again C. All right, Santosh, You're getting C? So what is happening, guys? What is the answer? B, D. Alright, Devendra is saying B. Unique Boy is saying D. Okay. Let's see. Let's find out. What is happening here? We've got a projectile motion on a train. Right? Not on the ground. On a moving train. So now if I say that, see, this is how the ball is going. You throw a projectile, this is how the ball goes. Right? And the train itself is moving in the opposite direction. Right? So now, can I say that for a person observing inside the train, you will have a particular maximum height, a particular range, right? Right? Okay, H max and R. But for a person that is outside the train and observing, for them, do you see that the velocity of ball with respect to ground is what they will see, right? So now if I look at it, since train's motion is in x direction only, I will say that ball's motion or ball's velocity along x component gets affected, right? Okay, so now I will say that, well, ball's velocity along x component will be equal to how much? Velocity of the ball with respect to ground is going to be equal to velocity of the ball with respect to train plus velocity of train with respect to ground. Right? And see, they are in opposite directions. X direction of velocity of ball is in opposite direction of velocity of train. Here we go. Ball ka X component is in this direction. Train's velocity is in opposite direction. So when I take these two vectors and add, I'm going to get a smaller value. Right? Okay. So effectively, I can say that for a person observing from the ground, X direction velocity has decreased, right? Not V, U. X direction velocity has decreased, projection velocity, but Y direction projection velocity has not changed, no change. What does that mean? It means that out of maximum height and range, whatever depends on X direction velocity, Ux, will change, but if it does not depend on Ux, it will not change. Right? Okay. So now I will say that the motion of the train will affect, see, the motion of the train will affect only the horizontal component of the velocity of the ball, while the vertical component will remain the same, as I've told you. Now, maximum height depends on only Y component, so it will not change, but range depends on X and Y both, right? So it will change. Here we go. So what do we have? Same H but different R, right? B is the answer to this particular question. Same H but different R. I hope you've understood this as well. Now let's move on and let's go to riverboat problems. All right. Last subtopic of today's session, riverboat problems. Right. So now in case of riverboat problems, again, it's an very easy, very commonsensical application of relative motion. Okay, say you have a boat moving in still water. That means the water is not moving at all. But if you have river, that means river is flowing on which the boat is moving. Right? So when you say velocity of boat in still water, effectively you're saying that out of both of these moving, rivers also moving, boats also moving, we have stopped the river. Right? If we stop the river, river becomes still water, and velocity of boat in still water becomes velocity of boat with respect to river. There we go. Velocity of boat with respect to river. That is velocity of boat in still water. Now, if I want to find out velocity of boat in with respect to ground, how does a ground observer observe this? Then I can say that velocity of boat with respect to river plus velocity of boat with respect to velocity of boat with respect to river is equal to velocity of boat with respect to ground minus velocity of river with respect to ground. So this over here becomes equal to velocity of boat with respect to ground is equal to velocity of boat with respect to river plus velocity of river with respect to ground. Here we go. Okay? Yes. Yes, Khushbu, range varies and H max remains the same. Now, if I talk about riverboat problems, this is the effective equation that you have to look at. All right, that's it, that's the basics. So now if I talk about downstream motion, when both river and boat are moving in the same direction, then the effective velocity, the velocity of the boat with respect to ground becomes, yes, scalar addition of both of them, because both are in the same direction, right? The magnitudes of the vectors get added up. And see, when both are moving in the same direction, I will say that VB plus VR gives you the velocity of boat as a resultant velocity with respect to ground. Okay? Now, if I talk about the other motion, upstream motion, what is happening? In case of upstream motion, when we do vector addition, these are velocities in opposite directions. So what happens? Yes, we have to subtract the magnitude, right? Velocity of boat is in opposite direction to velocity of river. So resultant velocity becomes equal to, yes, V is equal to VB plus VR, but then subtract the magnitude. So V of boat with respect to ground, magnitude becomes equal to velocity of boat in still water minus velocity of river. Okay, boat with respect to river minus velocity of river. Okay. Unique boy says, ma'am, I'm confused, please repeat. Okay, what are you confused about? Alright, here I'll repeat it. If I'm talking about upstream and downstream motion, right? Effectively, see, we got one equation, which was what? Velocity of boat with respect to ground, when you're observing a boat with respect to ground, right? Effectively, that's the velocity. That is equal to velocity of boat with respect to river, velocity of boat in still water, plus velocity of river with respect to ground, right? This is the vector relation that we get. Now, if both vectors are in the same direction, their magnitudes get added up. So what do we get? U plus V in downstream. In upstream, what happens? Their magnitudes are different, in their directions are in opposite direction. So their magnitudes get subtracted. That's all. So we get U minus V. That's all. Okay, upstream, downstream motion you've learned before as well, right? In 9th grade and 7th grade. This is the fundamental behind it using relative motion. Now, what happens when the boat is trying to cross the river from one side to another, right? Then what happens? Then we have relative motion in 2 dimensions happening, right? Yes, we've got x-axis, we've got y-axis. So, let's see. When the boat is trying to cross the river from one side to the other, right? So, यहाँ पे क्या हो रहा है? यहाँ पे we have reverse direction, reverse velocity, V river with respect to ground like this. But then since the boat is trying to cross the river, it's going from one end to the other end, right? Or it's at least trying to go from one end to the other end. W is width of the river. And here what happens is, if you try to go from one end to the other end, let's say the boat angles towards this direction. Okay. Boat aims towards this direction, making an angle theta. Then, due to the river current, the resultant of VBR and VR will give you the resultant direction in which they end up going. And this will give you a drift. This is the drift, that means the extra distance that they covered along the bank while crossing. Okay. Now here as well, you understand that since we are talking about 2-dimension motion, I can take the boat's motion along this direction and break it into 2 parts, right? One part along x-axis, one part along y-axis. And along x-axis, you see that displacement is drift. Along y-axis, you see that displacement is width of the river, right? So now I can say that time taken in x direction is equal to time taken in y direction, right? Okay, that's the basic of 2D motion. Remember in the beginning of the session we talked about it? Right. So time taken in x direction will be how much? Time taken in x direction will be equal to, yes, d divided by velocity in x direction, right? And what is velocity in x direction? Velocity in x direction will be equal to x component of velocity of boat with respect to ground, right? This is velocity of boat with respect to ground. What is its x component? VBR cos theta plus VRG, right? What are we doing here? Again, I have velocity vector boat with respect to ground is equal to what? We have boat with respect to river vector plus velocity of river with respect to ground, right? Now, when I'm talking about velocity of boat with respect to river, it is making an angle theta with x-axis, so it has two components, right? VBR cos theta I cap plus VBR sin theta j cap. So I'm going to write that. I'm going to say this is equal to VBR cos theta I cap plus VBR sin theta j cap. Now, when I talk about river's velocity, river is along x-axis only, right? River is flowing like this. So this is equal to VR I cap, right? Now if I take them together, I will say that x direction velocity is VBR cos theta plus VR. This taken from here, this taken from here. When I add them up, VBR cos theta plus VR, this is x direction velocity, right? So x direction displacement divided by x direction velocity gives you time, and y direction displacement divided by y direction velocity gives you time as well, right? VBR sin theta j cap is the y direction velocity. I hope this is clear. Now that you see this, right? X direction, time taken for x direction motion and time taken for y direction motion. They both are equal. This is the equation that you get out of it. And for any riverboat problem out there, okay, pay attention. For any riverboat problem out there, you can apply this relation and solve it at the end of the day. Okay, basic fundamental. क्या fundamental लगाया हमने? X direction का time is equal to y direction का time. अब यहाँ पे let's look at different cases, right? What if somebody wants to cross the river with shortest possible path? What happens then? If you want to cross the river with shortest possible path, matlab you want the resultant velocity to be along y-axis only so that drift becomes 0, right? Shortest possible path means drift is equal to 0. So if you want resultant velocity along y direction only, that means Vx should become 0, right? Okay. Now this is our original equation, right? For any general riverboat problem. If I talk about x direction velocity, do I look at this? This is x direction velocity, right? I want this to be 0. I'll say that x direction velocity equal to 0, Vx equal to 0 means VBR cos theta should cancel out VR, right? Velocity of boat in still waters cos theta component should cancel out velocity of river. If these two components cancel out, then resultant will be along y-axis. That means cos theta is equal to velocity of river with respect to ground divided by velocity of boat with respect to river. Magnitudes. Okay. So if you start at this angle with x-axis, right? If you start at this particular angle with x-axis, then you will cover with shortest path. Okay. Drift is equal to 0. Cost will minimize the distance. Cos theta, if you cover at this particular angle, then it will minimize the distance. Okay. We're not talking about cost here. All right. Are you talking about something else? I'm reading Santosh's comment over here. Okay. In any case, let's move on to the next part of it. So the next thing is, next specific cases, we talked about shortest path. Now let's talk about shortest time. What if you did not care about the path, but you cared about time? You were in a hurry, you want to cross the river in the minimum time possible, right? So then what do? Then you make sure that your velocity does not get cancelled anywhere, right? Okay, so here I will say that you want to cross the river in minimum time, right? That means you want y direction velocity, since your displacement, the displacement that you're interested in is in y direction, right? Effectively, you want to cross the river. Matlab, you are interested in y direction displacement. So you want to make sure that the velocity in y direction does not get reduced whatsoever. You want to go in that direction where velocity in y direction does not get reduced. So again, let's go to our original equation that we got for general riverboat problem. Here, time taken in y direction is w upon velocity in y direction, right? And what is velocity in y direction? VBR sine theta. Do you see this? VBR sine theta. Matlab, if I want y direction velocity to be as big as it can be, right, as much as I can, then I have to take sine theta as 1, right, sine theta equal to 1. That means I'm talking about theta equal to 90 degrees. Yes, that tells me that at theta equal to 90 degrees, I'm going to get shortest time to cross. And what will that shortest time be? That shortest time will come out to be W upon VBR. Okay? Alright. I hope you've understood this. Now that we've done this, let's solve one problem and then we will end the session. Okay? Let's apply this in the question. Come on, quickly guys, solve this question and tell me what the answer comes out. We have a swimmer in still water. Its speed is 20 meters per second. The speed of the water is 10 meters per second and it's flowing due east. If he is standing on the south bank and he wishes to cross the river along the shortest path, the angle at which he should make his stroke with respect to north is given by how much? Right? So, what should we do? Come on, quickly solve this question. Quickly tell me what the answer comes out. Naman is asking, ma'am, I'm in 10th grade. I don't know anything about physics. Can I crack it can I crack IIT if I do hard work? Please reply. Yes. Yes, you can. Definitely. All right. So, from somebody who's done this and I've taught students for about a decade, I can tell you that if you do hard work and smart work, you can crack it. Okay? No matter if it is IIT JEE or if it is NEET, at the end of the day, it is a marathon. It is a 2-year preparation, a proper preparation. If you do the marathon properly, you will crack it. Okay, all right. I hope, Naman, that you are ready to do the hard work and smart work. Okay? All right, I can see Santosh says D, Sharda says D. All right, Bikash says D. Let's see. What is the answer comes about? So, here we want shortest path, right? So, let's talk about it. Velocity of river is given as 10 meters per second. Velocity of swimmer with respect to still water is given as 20 meters per second. So, what do I say? If I want shortest path, that means I want x direction velocity cancelling out. That means I want VBR cos theta and VR cancelling out. There we go. VBR cos theta cancelled out by VR. That gives me cos theta is equal to half. Theta is equal to 60 degrees. And now we can see that. See? River is flowing towards west. And person is going from south. So this is south. This is north. And this is east. This is west. The person should go at 60 degrees, right? The person should go at an angle 60 degrees. So what is the direction then? The direction will be 60 degrees north of east, right? Here we go. The direction is 60 degrees north of east, and as you can see, thoda confusion aapko ho sakta hai because the diagram is such that west is coming out over here, east is coming out over here. It's given that the river is flowing towards the west, right? And here the river is flowing towards in this direction. All right. I hope you've understood this. I hope you guys are clear with this. Let's move on now and let's go to mind maps. Okay. Yes, Santosh, you are the first one to answer. I can see that. Now, I'm going to end this session over here, and the notes for this particular session you will find in the description. Okay, the link to the description will be there. And I hope you find these notes, and you should go through mind maps that are given after these notes. Okay? At the end of the notes, you will find mind maps. Please make sure you read them carefully. You take a printout of the mind maps and keep them in a file. I told you in the beginning of the session, right? I'll tell you what to do with mind maps. Mind maps are effectively your condensed notes of every chapter. Okay? At the end of every one shot session, we are providing mind maps. What you need to do is take these mind maps, take a printout, because I believe in offline, all right? So take a printout and keep it in a file for every chapter out there. Every night before you go to sleep, make sure you look at these mind maps, you read these mind maps, and it'll take only 30 minutes every day. But for 30 minutes every day, make sure you go through these mind maps and you will not forget formulas ever. Okay? Make sure you do these. After this session, go practice. Until next time, which is tomorrow. Happy learning. Bye-bye.